right, here we go. Let's go over this. So first of all, at the top of your paper, I hope you have Unit 6, Topic 2. This warm-up has to do with this, the discriminant. The discriminant is part of the quadratic formula. So this week, we're going to learn the discriminant. You have to take a quiz over it on Friday. So Friday, there will be 3 things on your quiz: simplifying radicals, adding and subtracting complex numbers, and the discriminant. Okay, next week we will use the quadratic formula. So let's go over this warm-up really quick. X squared plus 4x minus 5. Is there a GCF? Can I make an eye chart? Okay, so I have an eye chart of a -5 and a +4. The only numbers that give me 5 are 1 and 5. What about 1 and 5? -1 and a +5. So what's going to be in my first parenthesis? X minus 1. What's in my second parenthesis? X plus 4. Do I need to multiply or divide or do anything else? Oh, yep, +5. Sorry. Thank you. Woo, good thing you're paying attention. So good job, +5. So do I now need to multiply or divide or do anything else, or am I done? I'm done. Why? Because I was factoring, okay? Let's go look at number 2. Is there a GCF? No. Can I make an eye chart? I have a -15 and a +3. So I have 1 and 15, 3 and 5. Can I use any of those numbers to get a +3? Does it work? So this is not factorable. We cannot factor it, which means we would have to use the quadratic formula. So if you cannot factor something, you cannot solve it that way. You will have to use the quadratic formula. So we're going to go over the first part of the quadratic formula, which is the discriminant. Our notes are probably going to take about 10 to 15 minutes today because there's a lot of different scenarios we have to write down, okay? Then we will do some examples and you will be able to work by yourself. So our notes, the first thing you have to know is what is the quadratic formula. You should have learned this in Algebra 1, but we'll write it down. X equals -b plus or minus this square root. It's a big square root. B squared minus 4ac all over 2a. You gotta make sure it's all over it, not just the radical part. Everything has to be over the 2 times a. Okay? Quadratic formula works to solve any problem. So even though this one was factorable, I can use the quadratic formula if you choose to or need to. It takes more time, but it can be done. Now, where do all these A, B's, and C's come from? That comes from your standard equation, which I told you you have to memorize. Standard form, standard equation, whatever you want to call it. Your standard form is ax squared plus bx plus c, and it has to equal 0. So your equation has to be in this order in order to figure out what my A, B, and C are for my quadratic formula. Now, the part we're going to care about today is called the discriminant. The discriminant. The discriminant is just the part inside the radical, inside the square root. It does not include the square root, just what is inside. So my discriminant is just b squared minus 4AC. It's the part inside the discriminant. Okay. Once I figure out what my discriminant is, there are 3 options. So those are the 3 options we're going to write down. My discriminant, actually, before we do our 3 options, my discriminant tells us 2 things. Number 1, it tells us how many solutions. How many? How many is a number? 0, 1, 2, 3, 10. I'll tell you right now, your only options are 1 and 2. How many solutions? What's another word for solutions? Roots, zeros, there's one more. X-intercepts, okay? So my discriminant tells me how many solutions. My discriminant also tells me the type, or what a lot of programs call it is nature. It means the same thing. What type of solutions or roots or x-intercepts or zeros. You got to know all the words. So for my discriminant, I have 3 options. Option number 1, when I do my discriminant can equal 0. It will equal 0. If my discriminant equals 0, I will have 1 real solution. 1 real solution. What was another word for solution? That's going to help with my next question. X-intercepts. So if I were to draw a graph and I have 1 real x-intercept, what does that tell you about my graph? What's it going to do? Touch my x-intercept, my x-axis 1 time. 1 time. It can be on the negative side. It can be pointing down. It just touches my x-axis 1 time. Okay. Option number 2 is my discriminant can be greater than 0. My discriminant can be greater than 0, which means there's a positive number under my radical. If I have a positive number under my radical, I have 2 real solutions, 2 real x-intercepts. So if I were to sketch a graph, how many times would it touch my x-axis? It would touch it twice. There are 2 real x-intercepts, 2 real solutions. So it touches it twice. If you want to write that down, we can write that down. I forgot you on the first one. Right here, touch x-axis twice. You can write that down to help you. We can go back to the first one and write touch x-axis once if you would like to, so you know what it's doing. All right, my last option is my discriminant can be less than 0. Less than 0. Something's less than 0. What kind of number is that? A negative number. That's less than 1. Less than 0 would be a negative number. If I have a negative number under my radical, what have we learned about that? It's imaginary. So if I have a negative discriminant, I will have 2 complex. I'm going to write imaginary underneath because you can use either one of those words. 2 complex or 2 imaginary solutions. Think about what the word imaginary means just in general. If I have 2 imaginary x-intercepts, what do you think my graph will look like? How many times will it touch my x-axis? if something's imaginary? None. Thank you, Mr. Wheeler. It'll touch it none. It'll just be floating. It will touch the x-axis 0 times. It will not touch. So we'll go do some quick examples. We'll walk slowly through the first one and then we will speed up the other ones. Okay? Ready? Turn the page. Hurry up. Yeah, I know you're behind. You've just been sitting there. I know. I'm not waiting on you. I'm waiting on somebody else now. Who's been writing? All right, here we go. Let's go do some examples. If you didn't get it, I'll go back to it in just a second. Example number 1. I'm going to give us the problem 6x squared minus x minus 15 equals 0. So before I can start any problem, you have to make sure it is in standard form. So is it in standard form and does it equal 0? We're good to go. Now, I need an A, a B, and a C value. What is my A value? Not 6x squared, A is just the number. So what is my A value? Just 6. What is my B value? -1. And what is my C value? -15. So now I need to go figure out my discriminant. D equals, my formula is B squared minus 4AC. Whether you use a calculator or you don't, you have to use parentheses. Even if you plug it in your calculator without parentheses, it'll calculate it incorrectly. You have to use parentheses, okay? So my D, or my discriminant, B squared, that is -1 squared, minus 4 times A is 6 times C is -15. I personally think you're silly if you plug all this in a calculator at one time. Do the first part, do the second part. So what is -1 squared? What does that equal? 1. Thank you. You'll make me nervous. What is, I have -4 times 6 is -24. -24 times -15 is a positive 360. So what does my discriminant equal? 361. So you need to know 2 things. Number 1, does that discriminant equal 0, greater than 0, or less than 0? That discriminant is greater than 0. If my discriminant is greater than 0, how many solutions do I have? I will have, look at your notes you just took. If my discriminant is greater than 0, what do I have? 2 is how many? What type of solutions do I have? I have 2 real solutions. And if I have 2 real solutions, then how many times does it touch the x-axis? 2 times. So if I gave you a graph, it would have to touch it 2 times. Okay? Let's go to problem number 2. We're going to go a little bit faster. X squared plus 10x equals -25. Can I start this problem the way it is? What do I have to do? I have to put it in standard form, which means it has to say equals 0. How do I get it to equal 0? We're going to add 25. Where does it go? First, second, or last? All right. So my problem's going to say x squared plus 10x plus 25 equals 0. Take 5 seconds and figure out what A, B, and C equal. A, B, and C. A equals 1, B equals 10, and C equals 25. So now we can start our actual math problem. My discriminant equals B squared minus 4AC. Discriminant equals B is 10, so 10 squared minus 4 times A is 1 and C is 25. Do them separately. What does 10 squared equal? 100. What does 4 times 1 times 25 equal? Negative 100. So what does my discriminant equal? 0. If my discriminant is exactly 0, look at your notes. What does it mean? If my discriminant equals 0, what does it mean? One real solution, one real x-intercept, one real root, which means how many times does it touch my x-axis? One time. Questions? Very, very repetitive, yes? All right, last one, then here we go. X squared equals negative 2x minus 5. I'm telling you, these problems are easier if you leave your x squared negative. So it might look easier to move the x squared over, but I promise in the long run, it'll be easier if you move everything towards the x squared, okay? So let's add our 2x and add our 5. So my new equation is going to say x squared plus what? 2x, then what? Then what? Equals 0. Very good. Get an A equals, a B equals, and a C equals. I want you to try and work this one out on your own, but look up to check your answer. I would look up after you get your A, B, and C, and then I'd look up again to make sure you set your problem up correctly. A should be 1, B should be 2, and C should be 5. If you don't have those, you need to check something, please. Did anybody get a discriminant of negative 16? Some? Okay. So what do I know about my discriminant? Is it greater than, less than, or equal to 0? Less than 0. Y'all use some common sense. My discriminant is inside a radical. What do I know when I have a negative number inside a radical? It has to be imaginary or complex. So I will have 2 complex or imaginary solutions. What does that mean about my graph? What is my graph doing? It's floating, it's not touching, okay? Today in class kick, this is all you are doing is these problems that we just tried. You need to get pages 3 through 5. Most of you will get page 3 and half of 4 done, and that's okay. If page 3 takes you more than about 6 minutes, you need to ask for help because it should not. Okay? Second period, your class could